Hi everyone, and welcome to the AWS Nordics Office Hours with me, Gunnar Grosch. I am a developer advocate here at AWS, based in Sweden, and this is our weekly show where we bring on AWS experts to talk about a specific topic and let you, our viewers, ask any questions you might have. And if you have any questions, just pop them into the chat, and we'll do our best to get to the questions throughout the hour. And if we don't respond to your question straight away, don't worry, we'll try to get to every question when it is relevant throughout the stream. So every week, as I said, we have an AWS expert on. And this week, well, it's no exception. This week, I'm joined by Isaac Lenhart. He is a senior solutions architect based in Copenhagen. Welcome to the show, Isaac.
Thank you, Gunnar.
So tell the viewers a bit about yourself.
Sure. So I'm a senior solutions architect located here in Copenhagen. Been at AWS for a while, and in a past life, I've been a build engineer and a senior developer and done all kinds of interesting things along those lines. And most recently been working with companies talking around organization of how to do things securely. And that's what kind of led me to Proton here to dig deeper and see what's going on with it.
Yeah, you mentioned Proton there, and that is the topic for this week's show. We're going to talk about application deployment using AWS Proton. So let's take things from the beginning then, Isaac. What is AWS Proton?
Okay, so AWS Proton is an application delivery service, and it's a little opinionated about the right kind of structure of a customer that's going to be using it. So at a high level, what Proton is doing is it's separating the activities of operations and security and infrastructure people from the activities of developers or those who are writing code in such a way that it makes it more secure. It helps to define standard infrastructure in a way that not everybody has to be aware of all of it. Different teams can take control of different aspects of the infrastructure. And in a particular twist, it's very well suited for microservice type setups that you may have several microservices that need to share, let's say, a single environment while they work together on whatever business case they're trying to accomplish. Along with that, Proton contains CI/CD. So as part of the chain here, you've got people defining the infrastructure. You've got operations saying this is what this should look like. This is what our environment should look like. You've got infrastructure security saying this is what a service ideally should look like. Now, on the other side, you've got perhaps a developer organization that says, okay, that's all great. Now I have some code. I actually want to run this code. I want to click a button and have that code appear in this environment without necessarily worrying about all those standards that the infrastructure team may have come up with around that.
So some of the things you mentioned there, they seem to overlap a bit with other AWS services. Is it fair to say that?
Yeah, I mean, AWS offers a lot of different ways to kind of approach the code. And I think the way that you're developing your infrastructure, the way that you're setting things up, your kind of work chain from getting a product out there that somebody's going to use. And there is some overlap in the sense that I've seen out there some questions around service catalog in particular and how that may be similar or different from Proton. And it is true that there's a little bit of overlap, but you can think of this conceptually as being quite similar in its purpose, but Proton adds a lot more bells and whistles to help a particular kind of organization do it. So you take service catalog, for example. You have an infrastructure team. They come up with a template that says, this is a product. This is what this should look like. This is a deployed set of VPCs. It's got a database. It's got this kind of server. They set it up in service catalog as a product, and then they make it available. So some other person in the organization can come along and say, yes, I like that setup. I don't really have to worry about the way it's constructed. I'm just going to deploy it. That's very good. I think organizations should be actually doing that kind of approach. Proton acts quite similar in that it also allows you to set up environments, but then it also allows you as a second layer to set up the definition of what individual services might look like if they were to be inside such an environment. With Service Catalog, when an infrastructure team sort of says, okay, this is a product, this is what it should look like, this has all of our policies, this has our standards, it has all the right things in it that maybe nobody should be messing with later. Once it's deployed, that setup will exist, but then at that point, it's kind of up to the developer to kind of bang on it and use it how they want. What Proton is adding in this case is the ability for the folks that set up the infrastructure to kind of see what appears in it. They can also update important infrastructure setups with new versions. And they can also control on a more granular level what, say, the developer gets as part of a standard service setup. And all of this is, it's a little conceptual, so I'm going to jump into it a little at a time as we go. But that's kind of the big idea.
So who would you see is the intended user of AWS Proton? Which type of organization can benefit from it?
Yeah. So I've been talking with a few customers here, but one in particular who had a very strong operations and security team. So it's a whole team. They're very much trained on AWS. They're very keen on getting the right policies and security in place. They're using Control Tower. They're using organizations and SCPs to define who can do what, because this is very, very important to them. So they have a team that thinks very heavily about how default environments should be set up, how particular services should look like. And on the other side of the fence, they have a developer organization who also is trained up on AWS, but actually doesn't care that much about defining the policies, being aware of what security rules, what firewalls, et cetera, should exist in such an environment. All they know as the developer team, as the product team, if you will, is that they have a Git repo. It's got some code. It's running let's say a container with some code on it. And they say, I want to connect this container to one of these environments. And I don't want to have to worry about setting it up. I don't want to mess with CloudFormation. I want somebody else to define that for me. And then I can just easily just hit a button and boom, it's in like an environment with the right service. So to answer your question, I think if you've got an organization that is thinking very heavily about security and the right way to structure things and is very, very good about governance, this tool is an excellent way to expose and abstract a lot of those setup, environment, service templates to say, okay, this is what ideally we are looking for in terms of setup, and then present that to a product or developer team to say, okay, this is what you have. And of course, the team should negotiate on what's proper to have in a service environment. It certainly should not be just such a thick wall that they never talk, but it's a great way to automate and sort of inject those kind of definitions and make them easily available for developers.
And what type of customer solutions do you think is a good fit for this? You mentioned microservice-based architectures before.
Yeah, I mean, so if you think about I'm going to take this from the Service Catalog perspective. So when you go into Service Catalog and you say, okay, well, here is I'm not sure, a CMS setup with a particular PostgreSQL database, and I'm going to define this in Service Catalog and say, whenever we need a new CMS setup, this is the product I'm defining in Service Catalog. And therefore, any developer who comes to the Service Catalog and says, I need that, they can certainly go into Service Catalog and deploy that. Now, what AWS has sort of realized in a way is that for a lot of workloads, microservices kind of exist. And microservices is always kind of a loaded term. I always hesitate a little bit when I use it, but essentially, if you have teams that are creating small blocks of functionality, microservices that do one particular thing, and they all have their own release schedules and they all have like their own product release cycle, what you'll often find is that they may need to coexist in the same environment. They need to scale up and down as appropriate. They need to be released on different cycles. That's a little different than what you see in Service Catalog, which is almost more of a one-to-one kind of like, well, I have this, please deploy it. When you're dealing with a kind of microservices setup, something maybe even more serverless, you will probably find the need to say, okay, let's divide this a little bit. I need a standard environment in which microservices could exist, and I may deploy as many as I need into that because I know that one way or another they're all sort of talking to each other. So let's say you have a product microservice that's doing product related activity, and you have another one that's just doing orders and payment and billing, the kind of standard setup, and they're all being released on their same schedule, and perhaps by different teams who are deploying different code bases. Well, in a way, it's convenient and nice for them to say, well, you all belong in this kind of overall shopping cart environment or billing environment in which you can all exist together and yet be released and scaled and do all these things on your own pace. In a way, Service Catalog it's excellent for a lot of cases. But if you find yourself in the situation where you do need this sort of shared environment with its governance, and yet you have a lot of different microservices that need to talk to each other and perhaps share resources one way or another, that's a great kind of product setup to be using this in, if that makes sense.
It makes sense. All right, so we talked a bit about the background, what Proton is, why you would want to use it, and perhaps some of the use cases. But I think 12 minutes into the show, I think it's time to dive into actually showing something, don't you think, Isaac?
Yeah, absolutely.
So let's bring up your screen share and let's put that on. I think it dropped off before, Isaac.
Oops. Let's see.
Yeah, no worries. So if you just joined us, this is the AWS Nordics Office Hours with me, Gunnar Grosch, and today I'm joined by Isaac Lenhart, Solutions Architect at AWS. And we're talking about AWS Proton. There we go. And so now, time to dive into the console.
Okay, so to kind of grok, to get your head around Proton, and this is what, when I was talking with customers about this, and the customer I was referring to before had actually created sort of an in-house way to do this. There's obviously a need, and this is also true in another customer, but they needed their environment to be set up in a particular way, and then also to be able to define different services, the standard look of a service. So they'd already built this and in-house, but it required a lot of maintenance, and they were sort of spending time on that. And so when Proton came up, I said, oh, you know what, this looks actually pretty good. But it took me perhaps a day or so to really kind of grok the understanding of what exactly was going on. So at a high level conceptual basis, and this is from the Proton landing page here, you've got two sets of users. You've got administrators and you've got developers. Administrators are responsible for defining templates for two things. One is an environment template, and you can think of this as like, well, this is an empty container, a particular environment that contains some basic things that eventually a service will need to put into. So when they define an environment template, they're saying this is a kind of standard setup for an environment. When the administrator does this, they will then take this template and they will create one or more actual environments based on that template. So in this example here, we've got staging, production, and development, for example. It should be understood that these three environments are all based on that same template. So if there's a change to the template, it can be pushed to any of these environments. The other half of the puzzle is that the administrators also define service templates. So not only is it enough to have an environment with an ECS cluster and existing, now you need to say, all right, well, what does a standard microservice as our organization has defined it need to contain? With an eye towards this service will exist in one of those environments we've already defined. So an administrator who will probably work with developers, at least at the beginning, to say, okay, what should be in a standard microservice, right? Who knows? So they get together and they define the service template, and then that also is published. That kind of takes the hat off the administrator at that point. They go home and have a coffee. Developers, from the other side, are sitting there with some source control, and they say, okay, well, I've got some source for a container-based microservice that needs to actually exist somewhere, and I need to push it. So what a developer does at this point is they take that source code and they link it up to one of those service templates that says, okay, well, this is the standard setup of a service. And then they actually deploy it to a service instance, which ends up existing in one of those environments. So I wanted to kind of get the conceptual division here because it took a little bit to go, oh, okay, this is why this is happening. So I will dive here into the Proton console. So because some of this requires deployment time and so forth, I've kind of pre-baked a lot of these things just to show them off, but I will kind of run through them. So at a base level, you've got environment templates. So what is an environment template? An environment template is essentially at this point a CloudFormation template that says, I need this stuff in a standard environment. If we look at this environment template that I've already created, you can see that it's on a 1.0 and it's got certain things. And to help understand this a little bit, I'm going to show the actual definition of a CloudFormation template for the environment. So this example is taken from some of the public GitHub repos that we have. If you are interested in looking at any of this, there's a link out there to some of the public examples that we have. And I've picked a fairly simple example because as you'll see later, this kind of may explode into multiple services running on several environments. So I wanted to keep the code as simple as I could.
Isaac, can you just define what is an environment? What is considered an environment?
Right. So it's like a conceptual or logical. It's a container for a certain setup. Now, I think most people will gravitate to saying, well, this is a dev environment, a QA environment, a staging environment, a production environment, right? But you don't have to be limited by that. You could say, you could have several environments all in production that are basically based on the same template. So they all look the same, but they're all in production, for example. So that when you update the template saying, okay, this kind of environment needs to now look like this, you could update all of them. I tend to think that the typical use case would be, at least at first, using the single environment template and then putting it in a dev, production, QA kind of setup where they all look the same. Right. Does that make sense?
Yep, that makes sense.
So if we look at this, and we'll have to look at some code here to examine this. When you look at an environment template right now, what you're seeing is a CloudFormation template, right? So this is defining an environment. This is saying, okay, look, in our standard environment that we are creating here, it's got to contain a VPC. It's got to contain a subnet. It's got to contain another subnet. And some internet gateways, some routing, et cetera, a security group, execution roles, et cetera. So this is very kind of standard way of saying, okay, whenever we have an environment that can be reused, it's going to contain these basic building blocks. I think for your eagle-eyed viewers, you may see that in here, there are some commands that are not standard CloudFormation. These are Jinja parameters. And why? What does that mean? Because if I look at this, I say, wait a minute, where did this come from? So as you're using the console, and or even the CLI, if you are adding this template in as a potential candidate for an environment, it's going to want to have you inject certain parameters about how this is created on a level that can't really be done on the CloudFormation layer. When part of explaining this here would be to also say that next to the actual template itself, we have a manifest, which is saying, look, in order to create this environment, we've got this CloudFormation. We're going to run it through Jinja, and it's a type CloudFormation. One question that some of the viewers may be asking is, okay, so CloudFormation, is that what this is? And right now in preview, yes. You can define your complete environment here as a CloudFormation template, but on the roadmap in the future, on the public roadmap, there are ways they're looking at doing CDK, Terraform, other ways of defining the environment, and yet being able to inject certain Proton-specific parameters into it to actually create the environment in a specific way.
So there are some questions in the chat around Proton, CloudFormation, and so on. So are you using CloudFormation to define your Proton environment, or is Proton using CloudFormation for defining your infrastructure, or both?
Okay, so Proton is the general engine for taking a definition of an environment and taking a definition of a service, and then recording that, and then allowing you to instantiate actual existing copies of that. Today in preview, how you do that is you say, okay, I've got a CloudFormation template. This is describing what I actually need in this environment. Keep in mind, this is a template at this point. No environment exists. And I'll get to that in a second when I go back to Proton. But so Proton is a general purpose engine that's using CloudFormation here in preview. But in the future on the roadmap, it's intended to also include CDK or Terraform or other ways to define your environment, which then Proton takes that and says, okay, we got a template. Now we're going to go ahead and try and create the actual environments. Did that answer the question?
I think so.
Okay.
Cool.
Okay. So I'll skip back to the console here. So if we have defined a template here, it appears under environment templates here in Proton. And basically this is saying, well, version 1.0 of this template contains whatever I had in here. So it's got these types of inputs and so forth. If, let's say I want to create a new environment template. So just off the bat, I'm just going to create one of the kind of defaults. This comes with a Fargate and a Lambda samples. You can, of course, create your own templates. You can pull them from anywhere. In fact, if you do that, you simply have to upload it to S3 and do that. But it's at this point, for me, it's at least easier to just pick one of these for this demo and build it. And you can already see from this list here, Fargate and Lambda, it's already tending to want to talk about more serverless and microservice type setups, because that's really what it's going to be best at eventually. So as an aside, I should say that technically you can put whatever you want in the environment. You can skip Fargate, you can skip Lambda, you could just create an EC2 server and there it is, right? That's your environment. You don't have to create containers and all that, but as you'll see later, it's actually quite useful to only use this for microservices. So if I create like a template name, I'll say my default template and my default template. And I don't need that. And if I create this template, okay, now it exists. Now you can see it's registering here. So it means Proton has taken, what Proton is doing is it's taking this information here and it's saying, okay, this is a CloudFormation template. It's got a manifest, etc. And let's see, when are you done registering? That's usually pretty quick. Okay, now it's in a draft status, which means it's there, but nobody can actually use it. So we're going to actually publish that. And now it's 1.0, which means now this template exists. We can create things off of it. So if I go to environments, that was the template. That was the definition of what an environment should look like. You can now go ahead and create an environment. I now have my default template, or the one I already had, which is basically just a standard. And I can say, okay, well, look, I now want an actual environment based on this template as I defined it over there in the CloudFormation. Now, when I do this, let's see, new default environment. And I'm going to give Proton the rights to do specific things, act on our behalf as it processes this CloudFormation template. And this is the interesting one. So on this third step of actually setting up the environment, it's now asking us for some inputs. right? Which is specific to this CloudFormation template as we set it up. It's asking for the VPC CIDR, subnet CIDR, subnet 2 CIDR. And again, if you look back at the environment setup here, we can see that it's those 3 inputs that it's using as part of the UI here to inject in what the CIDR ranges of this particular template need to be. This is also defined down here in a schema, which is basically telling Proton, hey, whenever you deploy this, whenever you actually try to create an environment, I'm going to need you to ask for these parameters so that later I can inject them into the environment. Yep, so.
There's a question in the chat about the code language, and I suppose you can use both YAML and JSON for the CloudFormation.
Yes, I've typically only been using YAML, but it's whatever CloudFormation supports, I believe.
Yep.
Because in the end, like many things in AWS, it's CloudFormation if you dig down deep enough.
Right.
So this is deploying. So in progress. So what is this doing? It's actually going out there. It's creating a VPC. It's creating the subnets. It's creating the. I think there's an EC2 cluster in there as well. So
is this also visible in the CloudFormation console?
Yeah, you can see it. And in fact, as it creates these things, let's see. Again, Proton isn't doing this on its own. It's almost like a kind of a helper kind of application that's helping you do this. And if you look at the stacks here, I've got this new default environment named after what I did, and it's creating it right now. So right now it's going ahead and creating what it needed to create as I defined it in the CloudFormation template back in the project. Yeah.
Cool.
So from this point on, it's kind of like, well, it deployed my CloudFormation for me. The kind of, if you're used to Service Catalog, perhaps at this point you're nonplussed, you're not that impressed. That's fine. The other side of this as an administrator, though, is I might say I need a service template. So this is a service template, again, this is a template for something that should and will always exist in a particular kind of environment, right? Whenever a service exists, I don't have to define the thing that it's sitting inside of. That's already been done. That's the environment. What do I want a particular service to look like? So if we look at a template here, it also has a 1.0, et cetera, and it's a shared environment. If we go back to the code, here's an environment and a service. It looks quite similar. We've got the infrastructure, something additional called pipeline. If we look at the infrastructure of what a service should look like, because we knew that our environment uses an ECS cluster, and it's got a VPC and all that, we know that we don't have to define all these things in the service. We say later, this service will exist there and it'll plug in some things. So again, you can see some of these parameters that it's going to want to inject: the name of the service, the instance name, eventually how many instances you're going to want. I really wanted to point out, here we go, the environment. So you'll see this in a second, but when we go into Proton and we say, okay, I need a new service, you have to pick the environment, the kind of environment that it will exist into, right? And to do that, and the reason you kind of need to do that is because as it's deploying this service, it's going to take that cluster name and it's going to actually use that as part of this. So let me just hop on over to service templates. So I've got one already. So let's look at the services. I actually deployed 2 already, but we'll create another one. So again, this is a service template. This is saying, what does a service look like? It's our standard Fargate service template. As we create it, we're going to say,
who's doing this? Would it still be operations doing this?
Great question. At some point there, I subtly took off my operations hat, and now I'm a developer. Okay.
All right.
So as up to this point, the operations, security team, infrastructure, whoever has been doing the setup of the templates, and they've probably been consulting with the developers about how that should be done. I don't expect that unilaterally they would always say, this is exactly how it must be done. There must be some sort of conversation happening, I hope. But from this point, I'm now a developer, and I know that I have, let's say, a code project here. And in my code project, this is really simple. It's an index HTML contained by a Docker file. This is going to run inside a container, right? Could be more complex, but just for demo purposes, here it is. And I know that I need to hook this up and actually choose a service. So with my developer hat on, I'm going to come in here. I'm going to go ahead and create a service based on the standard template. There'll probably be a better description in there in a proper setup. And we're going to configure it, and we'll say demo service and demo service. And okay, so here's where we start getting more developy, right? Branch name. As a developer, I've got this code here. I've got 3 branches, dev, main, and QA. 3 different branches in my Git repository. Perhaps now I could hook up to any of them, but I'm going to say this is the dev branch. I'm going to hook it up to this particular repository that I have, and I'm going to connect to it. So this is giving me the permissions and where to go to get the code and which branch. So now I'm saying, okay, great. I'm going to want to deploy off of my dev branch into this particular service. Okay, service instances. So we can create a new instance of this service now, but you can indeed create up to 9 instances at once. And this is where kind of the power of like the microservice, like, oh, I'm going to want to do this a lot of times rather than service catalog maybe just once. So what I can do here is say, I want to add an instance of this code I'm running to be existing in this environment. I'm creating a service, but it's going to need to contain several instances inside of it. So let's say,
and the instances you're talking about now, that's not EC2 instances.
yeah,
Exactly.
no, it's not EC2 instances. You're not controlling the number of actual EC2 hardware that's happening. This is like a Proton service instance. It's a duplicated instance of that same service that also exists. And you might imagine you want this for just availability, or perhaps you are connecting specific applications to certain instances for some reason, and yet you're wanting to hook them all to the same source control, and you're wanting them all to exist in the same service and all in the same environment. So it's that kind of use case that this would be important for. So as I create this instance, I'm creating the service. I say, okay, well, this is the environment that I want. And you'll remember earlier when we created a service template, you could select which environment it should be good to go for. So we say, okay, this service, this instance needs to exist in this environment. And we will give it a unique name. And I would create multiple instances. It just takes longer to spin them up and all that. But you can create multiple instances of the same service within the environment. So it's this conceptual kind of like branching that I really want to get across today because the technicals of what it's doing are actually not that complicated. So I say in this build pipeline, we say I've got a Docker file, and then you can add some unit test commands if you wanted. So we say, here we go. We're all set up, looks right. And we're going to go ahead and create this service. So what is this doing, right? I, as a developer, took my took one of the service templates defined by the operations team. I said, okay, great. I've got some code. I want to hook it up to that. Please go make that, right? So in the selected environment right now, it is actually going and creating this instance of a service as hooked up to that particular environment. So one thing I'll show here is, because I kind of skipped over it, although I implied it, is there's a pipeline involved here as well. So this is the important CI/CD piece of this. If we jump back to here, when we had the environment, we only had the infrastructure because that's all we needed. When you have the service here, we didn't define the infrastructure of the service, but there's also this little pipeline here, right? So what is this pipeline? This pipeline is basically your build pipeline. So it's saying, okay, we need to set up a code build instance, and we're going to run this code, and we're going to run these commands as it builds it. And then for each instance that we had, we want to build a project and actually deploy it as an instance of this code, right? So this pipeline, and on balance, this is a pretty standard build pipeline. It's just kind of grabbing the code, building it, packaging it up, and deploying it. But you can modify this or spec it out however way you want. This is basically the definition of what the build pipeline should look like as you do it. So we've got roles and policies, getting from EC2, etc. So when we look at this, when we look at the build pipeline, that's what it's doing right now. It's going out to my Git, it's pulling the code, which again, remember, was just like an index contained in a container, but and then it's actually deploying it out to that actual service. So if we look at these services, and it's still creating, so maybe I'll just pull up one of the other ones that I did.
And in the meantime, if you just joined us, this is the AWS Nordics Office Hours with me, Gunnar Grosch, and today I'm joined by Isaac Lenhart to talk about AWS Proton. And Isaac has so far, first in the role of someone on the operations team, set up an environment in Proton, then switched over to his second job as a developer to create a service for whatever it is he has developed.
That's right. And I actually have two Git repos here with basically the same code. But one is, they're almost identical, except they have different background colors, just so I can show two different source things. We're starting to see kind of a expansion here.
Just a question on the pipeline you mentioned before.
Yeah.
So the code, to me, it looked very similar to the steps you have when you set up code build with CloudFormation. Otherwise, there were some small differences. But
nobody should think that this is like unique to Proton. This is a pipeline. This is a definition of a pipeline that will get run. There are some kinks here in the sense that it will pull in parameters from the Proton console, like the service name, for example, which it's injecting via Jinja. And I believe, for anyone worried about this, there may be something on the roadmap that has to do with like different ways to inject these parameters differently. I need to go check. But in this code pipeline, it's also taking certain parameters that you would have provided via Proton also, if that makes sense. So, I mean, this is basically a code pipeline and with certain instructions in it that Proton wanted to inject in real time.
Cool.
So if I look at my two repos, I've got like one that's got like a nice dark blue background and the other one, which is like a brown background, right? These are my two different code bases that I'm working with here. And please feel free to ask, because as I add branches and as I add services here, we're going to just get more kind of like variations on this. Originally, when I had set up two service instances here, we have one of these is working on the first repo and one is working on the second. And I believe for this one we just created, I think I pointed it at the blue one. Oh, it's still firing up. So basically the environment is there right now, but it's still creating those resources. To look at, I believe this one has the second one. Come on, buddy. All right. This is the brown one. So, okay. Now, let me talk about environments a little bit. If I'm actually creating environments and I end up creating dev, QA, production environments, typically we would say that you would put them in different accounts, because that's pretty much the right way to get a proper security and blast radius around them. I right now am creating this all in the same account. So I've taken a service template, an environment template called shared environment for Fargate, and I'm installing it as several environments all in the same account, right? Typically what you would end up doing is you would deploy these in different accounts, because you would want to have security on certain things happening in certain accounts, and certain environments only allow certain things to be created in them. And this may raise the question of multi-account usage of Proton. Proton is in preview right now, so it doesn't do everything that we would want it to do when it actually gets released. But right now, I believe that multi-account deployment is on the roadmap at some point. And then I believe that multi-region might be on the roadmap, so that you might be able to deploy across multiple regions. But for right now, because it's in preview, feel free to go into the roadmap and give a thumbs up and do whatever you need to do to make sure that it does certain things. Because right now, Yeah.
You've mentioned the roadmap a few times now, and just to be clear, that this is a public roadmap, so it is available on GitHub as a public roadmap. I'm pasting the link in the chat right now, so please have a look at that, and as Isaac said, upvote issues or help us define what's important for you when it comes to AWS Proton.
Yeah, totally. Because I feel a little awkward putting them all in the same account. I'm just like, oh, this is not probably what I don't want to do. But to kind of illustrate that better, I'm going to skip to another region in which I have a more comprehensive setup. So if you're with me so far, this is basically the same code base and everything else, but I've set it up a little differently. So I've got one environment template, right? And from that, I've deployed 3 environments, which are loosely dev, prod, and QA. And again, this is in the same account. Don't do this. Eventually, you'll want to do this in separate accounts. I have a single service template, which I said, okay, a container should run like this. I've gone ahead and created 6 different services. Each one of these, I'll explain this. So I've got 6 running services at this point. They're all the code that I've shown you before. These first 2 are running in the dev environment because when I picked the running of the service, I said I want it to run in this dev environment. These 2 at the bottom here running in the QA environment, so they're isolated from the dev, and the middle ones are running in production. By 1 and 2, I'm differentiating between the 2 code bases I have. So the blue and the brown versions of it, they're essentially the same. They use the same template and all that, but one is bluer than the other one. So in other words, I have 3 environments running, each with 1 copy of the same of a service running in each one, giving us 6. Okay.
We're with you.
Okay. So, and I think just like I said before, you can create up to 9 instances for each service. And I figured if I did this here and I have 54 different services running, it's gonna be kind of a long list. So basically, each one of these services is just running 1 instance of itself, right? But what this is getting to is I want to talk to you about versioning, because this gets back to the usability of this thing. Okay, I'm operations. I've defined a certain setup. I've said, okay, this is what an environment needs to look like. Now, I've already kind of done this because deployment always takes like too long for a demo in a way, or at least I want it to be done quicker. When I first did this, I did 1.0, which was like the environment that we saw earlier. It's a VPC, 2 subnets. It was everything that you saw in the environment infrastructure here, right? Standard stuff. Now, let's say you're an operations infrastructure type person, you're controlling this, and you said, oh, you know what, this environment needs to look differently now. Yeah, it's fine for what it did, but now we want to add something else, right? As an operations person, I'll go to a second version here. I created a version 2.0 of that same environment template, right? It has everything that was above it, but now I've added sort of a shared environment event bus. So this is the event bridge event bus, right? Because maybe I'm thinking, okay, I have this environment and I'm going to have all these services in them, but wouldn't it be convenient if they could all depend on some central thing that existed in the environment to talk to each other, right? So as an operations person, as I'm setting up this environment, I think, okay, it'd be great if maybe it had one single event bus that existed in this environment. Or maybe, I mean, again, you can pretty much put anything in here, but you could say, well, maybe they all need to share the same database, which to me is like kind of a no-no, but maybe in your use case, you do need that. Or you need SNS or SQS queues or something like that. You need something that no matter which services get deployed in this environment, they should exist in this environment once. So in this version, in this next version here of this environment template, I went ahead and I added an event bus, which ended up being version 1.2 of this environment, right? So 1.0 is still there. You can actually still go into an environment and say, oh, I want to create an environment. And I believe, unless I'm wrong, I think you can create it off of 1.0 still, or maybe you can't. Let's try it out.
That's a good one. So both were in published state right now, right?
Yes, and no, it's going to want you to use the latest, which I guess is pretty good. But I'll show you that after let's say I'd updated it to 1.2. I had these existing environments. They were all on 1.0, right? Originally, they had no event bus. What I did was I went into the dev environment and I said, okay, I want you to stop using 1.0. I want you to use 1.2. And maybe I'll just do that right now for QA. QA here is using the 1.0 version of the environment template, which does not have an event bus, right? But perhaps as an operations person, I say, you know what, everybody needs this event bus. It's super important. Or maybe you have new network standards. Maybe there's firewall rules. Something needs to be done about this. And as the infrastructure person, I'm going to come in here and I'm going to say, I want to update to the next minor version. Now, there are major and minor versions. Major versions are typically going to be things that completely break everything, or you expect them to. So when you're creating versions of these templates, you kind of select, as you kind of do with any kind of release process, like, is this major, is this minor? So I'm looking right now at the QA environment, which is on 1.0. And I think it here says, like, you're not using the latest minor. Do you want to? And you know what? Sure, let's do that. So I'm going to, that's fine. We're going to keep the same settings for the stuff that mattered. Ostensibly, I could have entered a new parameter here that said, what's the name of your service bus? But I just put it in the template. So we're keeping all that, and we're going to update this environment, which is now in progress. So what I would expect to see now is that, open that up. We've got dev on 1.2. We've got QA on 1.0. And we've got him upgrading right now to the 1.2. So as an operations person, I can sort of enforce without, I mean, you probably do want the input of developers to make sure you're not breaking something. But you could say, okay, you know what? We've got all these microservices. We've got hundreds of them running in here. I just want to update this in such a way that they all get this change without me really needing to worry about it. While that goes ahead and does its thing, let's go over to services. Service templates. So on the same vein, I have a service template. You've seen it before. I did roughly the same thing, which was, okay, now what happens if we add an event bus to a service template? So in other words, when the service gets deployed, not only is it a container task, it also comes with its own event bus, right? So if we were to deploy this, you would have into that 1.2 environment. The environment would have an event bus, but every instance of the service would also have its own event bus, if you see what I mean. So, and I can show that real quick. Let's see here. So also in the service template, I added an event bus. And here I parameterized it a bit with some of those parameters. Say, well, it's an event bus that is named after the service and its own instance, so that each one gets its own unique name. So we've got our 1.4 template out there. We've got these various services. Right now, I believe I upgraded the dev ones to, yeah. So the dev ones have the event bus, right? Yep. And then I think none others. So maybe I'll just pick QA. So you know what? This QA service, he definitely needs the 1.4, which is going to give him a, here we go. So we can see that this instance of the QA service is running 1.0, and we're just going to upgrade him to the 1.4, which contains the event bus. And something happened. Yeah. Well, let's see. Where did you come from? So we'll see if this goes. See if the preview gods are smiling on me. Oh, it's because I'm updating the environment right this minute. So
oh yeah, okay,
so that's fine.
And so the environment needs to finish updating first, or upgrading,
yes.
And then you're able to.
And it looks like the environment update had a problem anyway, so I would need to go figure that out. But the thing I want to show about that, just to illustrate the point, I may have fat fingered something in there. Oops. thing that I want to say about this is, so if we go look at EventBridge here, and all these event buses that we created, right? We know that there was one for the environment that the environment had in its template, right? And then previously I managed to update both the dev instances, each service to have its own. And so you can see like the name dash instance name here, as I kind of defined the service level instance bus as having. This is its name. So after updating one environment with the new version, he got his own event bus, right? That's the shared environment event bus. And then for two of the services that I updated, because they now each had their own event bus, we now are left with three. And if the QA one had succeeded a minute ago, you would also have seen one more QA bus, as I just was updating one service. Yes. So I mean, the reason this gets kind of hairy at this level, and this is part of the reason why something like Proton is actually useful, is I have three environments as defined here, right? I have a dev, I have a QA, and I have a production. And each one of these, I'm expecting to run code for one of my Git repos, right? So these green ones is one code base running a dev, and the other is the other code base running a dev, etc. In my Git repo, I have several branches. And then I can say, well, this branch should deploy to the dev environment. This branch should deploy to QA. This branch should deploy to production. Microservice 2, my other code base, I could do the same thing to say like, well, in the end, I should end up with a dev environment running code from the dev branch of two services running from the dev branch of each of my code bases. And the way this was set up, again, is with the environment template and the service template to actually come and create all this. So you might imagine eventually, I'm not sure I have a best practice on like how many services before you go insane in like an environment. Like this is constructed in a way that if you have a group of like very related but independent microservices that really should kind of be in the same environment, or like perhaps even as a logical workload kind of situation, I would say put as many as you want or makes sense to in a particular location. So if I had like 3 or 4 other code bases of microservices, I could deploy them all into these environments. And again, these orange boxes, these environments, they're all standardized from that single environment template based on a particular version of it. And then the services themselves are also standardized across the board. So as an operations person, if I want to end up with this situation, I'm going to create my environment template. I'm going to manage the versions, do some testing, make sure they actually deploy. I'm also going to define these service templates and say, okay, well, in conjunction with the developers, we've decided that the right setup for a service looks like this. And from that point on, the developers can just start pounding on new code bases, deploy them into the right environments, hook it up naturally to their Git branches and do whatever they like. Yes.
Cool. And I think you touched upon it there, but what if you are a developer, but you want to take care about the infrastructure as well? Then is Proton a good fit for that type of organization?
Yeah, exactly. So I think I said this is like an opinionated framework. Like Proton is a step above, where it's saying like, okay, if you've got the kind of organizational structure where you've got a group of people that really care about, the templates and how things should look, and we're enforcing the right policies, and you have another team that's kind of doing more of the development work, and they maybe don't care so much about infrastructure, cloud formation, and all that. This is a really good fit, because I've seen some customers where the ops when the infrastructure team is really into cloud formation, but the developers are like, well, before we can do any of this, we need training and like we need to get ramped up, and now I need to include cloud formation or IAC type information in my project just to be able to do this. If you are the kind of organization where you've got that kind of structure, like two kind of like communicating teams where they each kind of worry about their own backyard, this is great, because then developers don't need to worry about what's going on in the infrastructure as much. And then from the other side, you can actually tell as an operations person, you can go into a service instance and say, okay, how's this running? Where's it running? What happened? And kind of figure out what is running and what version it's on. In Service Catalog, by comparison, you're kind of blind to what has been put into the deployed product. You know what I mean? So you've said, oh, this is a great product. Somebody deploys it. You're kind of blind to like, well, what version is it on? What's running? And so Proton gives operations a lot of tools to do that. On the flip side, just real briefly, I'll say that if you're the kind of organization with like a strong DevOps and all your developers and are all deeply into doing CloudFormation, IAC, and all that, and you're all trained up and you're perfectly comfortable, I don't think this tool will give you as much value, but I think it's a good tool to use to set yourself up for that kind of division in the future. Because if you are simply the same developer who's going into environments and you're creating templates and you're creating service templates, and then you're basically the same person putting on a different hat and then you're hooking it up, you probably will chafe a little bit, but I think it's almost like good medicine, because in a way you want to be set up in the future so that you could make that kind of team division. Because really, in the end, as companies grow, I see them divide themselves into that kind of responsibility, where it's like, well, these folks are responsible for all the security and infrastructure, and these folks are responsible for delivering business value on specific code bases, if you see what I mean.
Right. There was a question in the chat as well earlier from Carl about the desired minimum state of an environment. How small should or can an environment be?
Oh, well, okay. So, and again, this is under the hood. It's CloudFormation. So, if your environment doesn't have anything in it except maybe like one thing, or like an environment could contain whatever you like. So, I haven't tested this. So I guess you could maybe do an empty CloudFormation, but you could, let's say you just at a minimum said, I just want one Lambda function, or let's say you just want a database, an RDS instance. You could do that, and that's the environment, right? Maybe it's something more serverless, in fact, but you could just say, well, our standard environment doesn't contain very much at all. It just contains like this one thing. I don't think you're getting a lot of value out of that, because why'd you do it? But because the other side of this is that, why are you creating templates? You're creating them so that they can be reused, so that whenever one of the development teams approaches you and says, oh, we got this great new idea for a particular kind of functionality. Do you have something already set up and vetted and policied up that does this kind of area? And you can say, yes, we have that. If you are making up environments that are sort of like one purpose, one use, or they're very like customized for a particular thing, that's not going to give you as much value, because you'll just be like, well, this was the environment that was specifically for the Acme project, and that was it. Nobody else can use it because it's too much.
Yeah.
So the more you can kind of standardize these and contain enough to be useful, but not too much that it's overloading somebody that might create a service that goes into that and says, why is there so much junk in this environment? I only needed blah, blah, blah. You know what I mean?
Right. All right, Isaac, 1.5 minutes to go. So any finishing words around AWS Proton?
Yeah, I mean, I've dabbled in the black art of build engineering and so forth in the past. But I think the real power of this is the way that it's going to allow certain customers to reinforce their organizational structure. So the under the hood stuff, the CloudFormation, the build pipeline, and all that, it's relatively straightforward, actually, if you get into it. And I encourage everyone to go to the examples we have out there. But the real power you're going to find is in enforcing organizational boundaries, getting proper security in, and doing it in a way that's really quite tuned for doing microservices. And also it has the power of doing a CI/CD type behavior, like in the box. You just say, I've got this Git repo, please deploy it according to that template that I wanted.
Right. So I guess we'll finish with the standard phrase of try it out. Yeah, I think that's usually the case. We end these shows. So Isaac, thank you very much for joining us talking about AWS Proton today. No problem. Thanks to everyone watching. Hope you was able to learn a bit more about AWS Proton. And join us next week when we'll talk about Amazon Connect, the cloud-based cloud-based call center from AWS. Very exciting. All right.
Yeah.
Thank you, everyone, and
Thanks,
have
everyone.
a good day ahead.